questions 21 through 25 on the 2014 Grade 8 AMC 8. The 7-digit numbers are each multiples of 3. Which of the following could be the value of C? If this is a multiple of 3 and that is a multiple of 3, then the sum of the digits are also a multiple of 3. Sum of the digits, and that's the key to this question. So in the first one, we have 7 plus 4 plus A plus 5 plus 2 plus B plus 1. And when you add up those numbers, you get 19 plus A plus B. And this must be some multiple of 3, so 3 times K, let's say. Well, just by inspection, I think 21 would work, 19 plus A plus B, and it would work if this is 1 and this is 1, right? Just something basic, straightforward like that is sufficient. Now let's look at the second guy. So we have 3 plus 2 plus 6 plus A plus B plus 4 plus C. All right, let's substitute the fact that we have 1 for A and 1 for B. And when you do, and you add up those numbers, you get 17 plus C, right? So 17 plus C now has to be some multiple of 3, 3m, let's say this time. Well, how can we get that to be a multiple of 3? Well, C could be 1. If C is 1, 17 plus 1 is 18, and 18 is a multiple of 3. And that's it. So C is 1, and therefore number 21, the answer is A. A two-digit number is such that the product of the digits plus the sum of the digits is equal to the number. What is the units digit of the number? So we have some number, A, B, it's 2 digits. They're saying that the product of those digits, so A times B, plus the sum of the digits, A plus B, is equal to the number. And the number is 10A plus B. Why? Because if you have a number like 57, 57 is really 5 times 10 plus 7. So that's why I have to put it in this form. Okay, so this is just A times B, and then if we get rid of the B's, we get 9A. Cancel out the A's, and we get B is equal to 9. And that is indeed the units digit. So number 22, the answer is E. 3 members of the Euclid, which is a math contest in Canada for grade 12, interestingly. Middle school girls softball team had the following conversation. Ashley says, I just realized that our uniform numbers are 2-digit primes. Bethany says, and the sum of your 2 uniform numbers is the date of my birthday earlier this month. Caitlin says, that's funny. The sum of your 2 uniform numbers is the date of my birthday later this month. Ashley says, and the sum of your 2 uniform numbers is today's date. What number does Caitlin wear? Well, the fact that they're 2-digit primes, we only have a few of them. 11, 13, 17, and 19. Now, there's a lot more 2-digit primes, right? But these are the only ones that I want to consider. You say, well, why? Why not go further? Well, because when you're adding them, they've got to be dates of the month. And as you all know, the dates of a month are anywhere from 1 to 31. So if I go higher, so I think the next prime is what, 23? You would think I would memorize all this, but 11 plus 23 is going to be 34, so there's no way that's going to be a date. So these are the only 4 primes that are in contention here. Okay, so 2 of them added together has to be a birthday earlier in the month, later in the month, and today's date. Okay, so what are the possible sums? 11 plus 13 is 24, 11 plus 17 is 28, 11 plus 19 is 30. Do we get any different sums? 13 plus 17 is 30, 13 plus 19 is 32, and that's way over. Well, it's not way over, but it's over, and 17 plus 19 is 36. So these are the only possible dates. Well, the one that's earlier in the month must have been the 24th. The one that's later this month is most likely the 30th. And the one that is today's date is 28th. That would make the most sense. Okay, now we have to assign the uniforms. So Bethany says the sum of your, so she's talking about Ashley and Caitlin. Okay, so Ashley and Caitlin's numbers add up to 24. All right, so let's say Ashley is 13 and Caitlin is 11 in terms of their uniform numbers. So that means that Bethany must be, well, we'll figure it out. Caitlin says that your two add up to my birthday, which is the 30th. So that means Bethany and Ashley must add up to 30, so this must be a 17. And I think this is the only way to do it, 13, 17, 11. All right, so Caitlin, what numbers does she wear? She wears 11. So number 23, the answer is A. One day, the beverage barn sold 252 cans of soda to 100 customers, and every customer bought at least one can of soda. What is the maximum possible median number of cans of soda bought per customer on that day? Well, we have to figure out the median, which is an interesting question. So we'll rank the customers, the first one, the second one, all the way up to the 49th customer. Then we have the 50th customer, the 51st customer, and then we go all the way to 100. Now, the median will be these two guys, their average. Well, the first 49 customers, if they all bought one can each, then of the 252 cans, we've got to subtract those 49. And when we do, we get 203. And then if we want to divide this 203 into the remaining people, that is only going to be done as follows. Everybody's got to have purchased 4. And if you do that, this guy is going to have 3. That's the way the math works out there. Because essentially it's 50 times 4, which is 200, plus 3. So now we just want the median of these two guys, and the median obviously is 3.5. And I've done it in a way so that the median is maximized. And that's what they really wanted. And that's pretty much all there is to doing this question. So number 24, the answer is C. A straight 1 mile stretch of highway, 40 feet wide, is closed. Robert rides his bike on a path composed of semicircles as shown. If he rides at 5 miles per hour, how many hours will it take to cover a 1 mile stretch? 1 mile is 5,280 feet. Well, first and foremost, we have to understand this question a little bit. So 40 feet wide, so from here to here is 40 feet, right? Well, if this is a semicircle, then this would be a circle, and that line would basically represent the diameter. So this is also the diameter if you draw it that way. So the diameter of those circles is 40 feet. Now we want to go along a stretch that is basically 1 mile long. So 1 mile is 5,280, and we're going to have to divide by 40 to figure out how many of those diameters are we moving along. And if we do, we get 132. So 132 diameters is how much we're moving along in this 1 mile. Now each diameter represents a semicircle. So we have to multiply 132 times the semicircles. So there's 132 semicircles basically. And each semicircle has a circumference of circumference divided by 2. Circumference of the circle divided by 2. So 132 times the circumference divided by 2 will give me the total sort of distance that he's traveling, like that, since he's going like in sort of this weird pattern. Okay, this is basically 66c. Now what's c? C is the circumference of the circle. And the circumference of any circle, I'll write it over here, is pi times the diameter. All right? So 66 times pi times the diameter, which is 40. So this is the total distance that he travels. I'll just write that here, total distance that he's traveled. Now we're not asked to really find the total distance. We want to find hours. We want a time here. Okay, so that formula we're going to use is speed is equal to distance over time, isolated for time. So that's time is equal to distance over speed. So time is equal to distance. Well, distance we just figured out was 66 times pi times 40. And the speed, 5 miles per hour. 5 miles per hour. So we have to multiply this by 5280 to get feet per hour, because this is all in feet. So I've got to get the denominator in feet per hour. This is in feet up here, and this was feet per hour. Okay, so now we can just do this math. And when you do, you crunch out these numbers, you basically, it all just boils down to pi over 10. That's it. So number 25, the answer is B.